Hello, everyone. Good morning, good evening. Thank you so much for taking the time to join us. Welcome to the very first AccelEdge webinar. We're going to be talking about YARN Optimizer. So along with me, I have the speaker, Adnan, and we also have our SME, who's going to be helping us with any questions that we might get from our audience. So without further ado, let me pass it on to Oh yeah, before that, quick information about Q&A. In case you have any questions for us, you can feel free to add it to the questions window in Zoom. In case we're not able to get to all of your questions, be sure to also uh, drop your questions in the discussion forums. The link is provided there. We'll ensure that we'll get back to you if you're not able to answer any questions here directly. With that, over to you, Adnan.
All right. Thank you, Pratik. Thank you for setting this up and thank you for organizing the sessions. I know this is a stepping stone towards AccelEdge, and step by step, I know this edge will convert to a big stone for us, and we will help customers in whichever possible way we can and share as much as knowledge through these sessions going forward. So we have piloted this with this first project and with this first component that we have. I won't say first project or first component, but basically a new innovation in the field of YARN optimization. And I am proud that I get to work with an organization, which is Acceldata, absolutely, that comes and thrives for all these kind of innovations that will help us to solve the industry problem, right? So the topic that we're talking about and discussing about is YARN optimizer, right? So this has been an ever-growing challenge with every organization with YARN. So I just want to set the context before I dwell into slides and much more discussion there, right? So the agenda is very clear here, so I don't want to speak on the agenda, but I want to set the context first, right? As many of you who are in this call or who will be listening this call down the line, right? You know, the biggest problem that we have been facing in YARN is we end up provisioning and adding more and more nodes to the cluster without really realizing how much of this is really being utilized by the containers that we have deployed and how much of this is going wasted or the potential is there to come up with more containers. In short, right, we are giving maybe 100%. Let us say we have provided 100 GB of data to YARN containers, right, or be it the entire YARN process for running the containers, right? Let us say I was assigned 100 GB. Though you see 100 GB is being utilized, right, in YARN UI, but not that entire 100 GB is utilized per se. Of those 100 GB, let us say you have spin up like 20 containers, each of 5 GB size. Not necessarily each container which is requesting for 5 GB of size is utilizing it. And over a period of years, we have realized that, hey, this is an industry problem, right? And now we know that we are charged on two things, right? It is CPU utilization and memory utilization. So though even we are being charged by an in cloud environment, this is highly relevant, right? We are being charged for utilizing or requesting for 5 GB, but if you have not utilized the entire 5 GB, but you still pay for it. So that's when the entire engineering team sat over this and we wanted to basically come up with a solution and unlock this problem. And that's where we have YARN optimization, one of the solution. So I'll just quickly walk through, what is the YARN cluster overview and YARN optimizer, how it helps you to, unlock the resources that are unutilized, architecture, a short demo, and then what are the production cluster ROIs that we have seen over a period of 8 to 9 months from different customers, and open for question. So Pratik, next slide, please. Right. So as you know, I won't spend much of my time here. As you know, as you have been working on YARN cluster, the architecture is very simple. It's a server and client architecture. So you have something called as resource manager that manages the resources, and node managers, which have the potential to run the clusters and also come up with actual resources in terms of CPU and memory. So net, in short, if you ask me what is YARN, I call it's a distributed operating system. So if you have worked in any kind of operating system in past, YARN is exactly the same thing. The only difference that we have in other operating system as compared to YARN is all those operating systems are restricted to one particular system. Now here we have designed a system that can, grow expands across multiple nodes in the cluster and does the resource management. So exactly what the resource managers does in the OS world as well. So just to let you know, consider this as a distributed operating system for people who are novice to, and who want to understand what YARN is. I think in single statement, it is a distributed operating system. Right. So moving to next slide, very important. This is where I want to set the context, right? So let us say on a particular server, right? Let us say the entire resource manager that you have, right? You see 32 GB of memory, for example, right? And of that 32 GB of memory, I will definitely correct that lower section. That was something I've realized now. It is not a resource manager node, but let us say at the entire level, right? You have assigned a particular node manager which has 32 GB of memory. Of those 32 GB of memory, you have reserved 8 GB for OS, and remaining 24 GB is for your node manager. Now, on those node manager, right, you can spin n number of containers, completely depending on the container size. So here is a classic example wherein the container size, we have spent 3 containers of 4 GB and 4 containers of 3 GB, which sums is up to 24 GB. So when you allocate, with the moment you request a container on a particular node manager, whatever the request is, it will accordingly assign that much of memory from the OS. Right. So here it's a quick sneak peek to understand that, hey, we have assigned 24 GB. Now by this setup, right, we are able to spin 7 containers. And the distribution across those 7 containers is we have 3 containers of 4 GB each. Those containers, when they spun up, they had requested 4 GB each, and 4 containers have requested 3 GB each. And just to let you know where this is configured, in YARN level, you configure that at what resource memory is allocated from each and every node manager. So next slide, please. So just, extending more on something that we've discussed in the previous slide, right? If you see, you have allotted 24 GB of memory for node manager. Of entire 24 GB of memory, you were able to spin 7 containers so far. Now I'm specifying it. I'm going into those nitty-gritties just to help you understand and how many containers we have actually spin up, right? So we have spin up only 7 containers so far. And if you see in each of these containers, right, let us say in the first container, for example, right, we have requested 4 GB as a container size, but we have not utilized the entire 4 GB. And that is what you will realize over a period of time, right? If you have been working on YARN for so many years, right, you'll see that, whenever you run top command, right? And if you talk about the resident memory, if you're aware of, so you will see that, hey, even though you have requested for 4 GB for that particular container, the resident memory usage will only be 3 GB. So it is very difficult even to gather that detail, which I'll come to it later. So if you see in similar fashion, right, across all the containers, let us say it is distributed in a fashion, you have been utilized 3 GB in the next container. If you see, right, the difference is huge. Though you have requested for 4 GB and you are requesting 0.5 GB. Right now, question would be that, hey, why would someone do this? This usually happens in any infrastructure and every infrastructure because every developer ensures that his code or the job that executes has sufficient amount of memory, right? So they always add good amount of buffer to ensure that their code does not, get killed because of problem, right? So it is an industry practice, right? And this is not something, a new problem statement that we have innovated, that, hey, we are utilizing only 4 GB or we are assigning too much. This is an industry problem. That is what we have seen over a period of years. And even if you analyze your clusters today, right, you will see exactly the same thing. It's not like if you have requested for 10 GB, you are utilizing the entire 10 GB. If you have requested for 5 GB, you are utilizing the entire 5 GB, right? To know the exact usage, you will have to go to the resident memory and understand, how much is the exact usage there. So with this slide, what we are trying to showcase is of the entire 24 GB that you have requested, you have utilized 13 GB and you have unused 11 GB. It's almost like 50% of your usage. 50% is wastage. And you are utilizing only for 50% of it. Whether it is half empty or half full kind of thing, right? And this can change, right? It can also at the extreme ends at both sides, right? It can be, hey, though you have requested for high containers, but maybe you end up utilizing only 20% of it and 80% of its wastage. In such circumstances, right, this is a solution that will ideally help you to solve the problem and utilize the cluster to its fullest. So I hope you are able to relate it to the existing cluster that you're working on. So this use case is exactly for the customers and for situations wherein, you are utilizing only 20-30% of the allocated resources, or maybe even 40 or maybe 60% of resources. Forget about even 70% resources. But if when I talk about 70 and wasting 30, that 30% is actually costing your pocket, right? It's not coming from, from heaven to us, right? So we are being charged for it. And that's where we have realized that, hey, this 20-30%, whatever that number be, if we are able to help customer to save even 10% of it, right? It's a big saving in dollars, right? So with this slide, I want to set this context and make it clear that, hey, the total memory assigned was 24 GB on YARN containers. We have spun up only 7 containers. Of those 7 containers, we have utilized only 13 GB. The remaining 11 GB is wasted, which is almost like 50% of a cluster is wasted. Next slide, please. Now, this is a quick sneak peek and just want to introduce, Pulse as one of component that Pulse is one of a product which helps to understand what is the usage at each and every job level and how was the execution of a period of time. So this is a classic representation of one of the job which was run by user Smith, ran in marketing queue. And this gives you a quick sneak peek to understand that, hey, what was the execution time? How much memory it has utilized? What was the input read? What was the time elapsed for this particular job over a period of time? Something that I just want you to quickly look into this is if you see the memory utilization, right? Something that is in green, right? Dark green, the memory utilization has been hovering between almost like 19 GB, right? We are not really sure if we really need 19 GB out of this. Right? So average memory usage, if you see for this particular job, is 19.67 GB, almost like 20 GB there. Right. So we just want to also introduce you to some of the dashboards that we use, and that will be helpful for you going forward to understand how is the usage over a period of time. Next slide, please. These are some of the metrics that will help you to understand what is the CPU distribution, usage distribution, shuffle information. So if you are coming from Spark, you will be able to relate it. HDFS information, how many IOPS in and out, and then storage memory utilization across. Right. So we just wanted to let you know that all these metrics are available in Pulse dashboards and how we will utilize and capitalize this to understand what difference YARN Optimizer will really bring as we dive more into the sessions going forward. Next slide, please. So yeah, so now this is where we unlock the potential to utilize that wasted 11 GB that we spoke about. So what we do is based on predictive analysis and reactive analysis, right? So we run 2 algorithms basically in backend to understand that, hey, what is the current metrics and what was the pattern of the particular job execution. Based on that, right, we come up with some certain overcommit ratio or overcommit number. Again, this number is configurable. I do not want to get into the configuration right now, but just want to set the context that how are we solving this problem. So if you see in the previous slide, right, we have utilized the total memory was 24 GB. Of those 24 GB, 13 GB is utilized, 11 GB is wasted. Now we are overcommitting this by 8 GB, right? So now how we are overcommitting, what are the mechanics, what are the, how it really calculates, there are many configurables that run around. So it is the optimizer that tells YARN that this node has 32 GB of total container memory. All right. Now YARN container allocates additional containers to this node. Very simple. All right. So what I mean to say is the most important thing before driving further into this, right? We are not doing any change at YARN end. We are not adding any new hooks at YARN end, right? So this operation, whatever we are doing, is just with the help of APIs. So I want to set that very clear and upfront that hey, there are no code changes. You will continue to use the YARN that you are using today. What we have capitalized on is the APIs that RM exposes. So we utilize that APIs, and then we say that, hey, instead of this particular node manager, until now you were considering it to be only 24 GB, we come up with certain metrics, certain calculation, and we say that, hey, it is no more a 24 GB node, it is a 32 GB node.
Yeah, just to add to what Adnan has said here. So what we do is we have very lightweight, intelligent agents on all the node managers, which periodically and real time calculate and find out what are the YARN containers that are running on each node manager, find out their resource usage pattern, and send it to, Pulse servers, and then predict that, okay, what is the requirement for each different application or container, and then use those numbers to arrive at the overcommitment ratio and numbers.
Perfect. Thanks, Viksan. Thanks for chiming in this. But again, the important point that I want to stress on is we are taking two factors into consideration while we come up with this number, right? One is the real-time analysis of the node manager that we continuously capture the metrics. And at the same time, we are also seeing the past behavior of how a particular job that ran, how much memory it has requested in past. So if that job is scheduled on this particular node manager, how much memory it will utilize. So we have a small ML machine learning algorithm that is created that helps us to do this analysis. All right. So if you see with all this change, right? If you see, right, of the 24 GB of memory, now we are telling Yarn that, hey, you do not have just 24 GB of memory. Now we have pumped up another 8 GB into it, which makes it to 32 GB. Now you were previously using 13 GB. Now we have unleashed that potential to use, or we have unlocked, and you can use that for 5 GB now, right? So we had it 18 plus 11 plus 8, which makes it 18 for you, 9. Of those 18, though we are overcommitting it and you were not able to utilize it. Now, since we overcommitted, it knows that, hey, I have more memory to utilize. And that's where this wastage really gets utilized now. All right. So now in this situation, you end up using 18 GB of memory instead of 13 GB. All right. Next slide, please. So quick architecture diagram, how do we really work on this? And the reason I want to, we have specifically included this in this presentation is to let you know that we are not touching your RM, right? We are not, doing any code level changes in your resource manager, right? This is completely handled only via APIs and via the containers, the Docker containers that we run on Pulse nodes and on each and every node there. So we have this YARN Optimizer, and then we use ADML as one of the container, which does the predictive analysis for the previous jobs that were executed. And then we continue to capture the new metrics. So we kind of marry both this data, and then we come up with the overcommit ratio. Right? Next slide, please. A bit of architecture diagram. Again, I just wanted to drill down further, double click and understand how it fits in the ecosystem. So at extreme end, both the ends, you have your node manager and you have your resource manager. You already have the node metrics collector that runs. So between your node manager, your resource manager, we have introduced this new segment that is called as overcommit resource calculator. So if you see as default, the first step is it registers any new event to the RM. Now then RM will send back the resource allocation metrics to the overcommit resource calculator, which will eventually also send it to the node metrics collector. Node metrics collector will also get its data, right? It will also push its metric to the overcommit resource calculator. We will come up with an overcommit ratio, and then we pass it on to RM. And now that your RM has more memory, now it has realized, let us say at the entire RM level, before introducing YARN Optimizer, let us say if it is 100 GB. Now with all these steps, at the 6th step, it will say, okay, I have an overcommit memory of maybe 10%. So in that case, now in your RM, you will at least see 110 GB there. All right. So again, we'll follow the process and will help you to understand the NM will register with your RM, which is an idle process, but it will register the node event. Your RM will send the node resource allocation metrics to the overcommit resource calculator. At the same time, you're getting the metrics also from push node metrics, which will continuously send what is the utilization, how the metrics are, memory utilization and CPU utilization. So we are getting the metrics from both the ends. Then we calculate node's resource to overcommit, and then we node resource update event, and then schedule resource on the node as per YARN application request. So the intention of bringing this slide is to help you understand in this eco space of node manager and resource manager, how we fit ourselves. Right? Next slide, please. So this is a quick demo, which will help you to understand. And so we have done a recording of this so that, if usually what happens in this live demos, right? Either you have VPN access controls, your network is slow and whatnot, right? So we have recorded this session, but I'll walk you through exactly how things will transpire, right? So yeah, this is a quick video. So if you see here, your cluster has total 312 GB of memory, right? With 40 vCores, so we are not stressing much on vCores right now. We have 4 queues here, that is root, and then default, development, scheduled, and priority queue. The default queue is something where we'll do our investigation on. So the default queue size is 95 GB. And this is where we will run our jobs. So yeah. So if you see here, the effective capacity that you see on the column there, it is 95 GB. Right. So now what we'll do is we'll run the jobs in this development queue. And then we'll see that, how the resource utilization grows. And at one point in time, so currently this is not, we are on default capacity strategy. So we are running it as it is. So we are spending around like 17 executors, each requesting 5 GB of memory, which makes it 285. And the queue size is 95. And now we'll run multiple jobs in the same queue, development queue. So we'll have the first job that will run because, it is less than 95 GB. But then when we run the subsequent jobs, all right, this is the first job that I've run. You'll see it's going in accepted state, and then eventually in running state. Now we'll run more jobs in the same queue. The requesting the same amount of memory, not to that extent, but in one executor. So here, if you'll see the utilization of development queue, yeah. So now if you see, it is 100% utilized, right? So 95 GB is the effective capacity, and we have utilized more than 95 GB. Now we'll run few more jobs in the same queue, and eventually we'll see the jobs will end up, because lack of resources, will end up seeing all these resources stuck in accepted state. Right. So nothing new for people who have been working in YARN. It is expected that, hey, if you do not have enough resources, the jobs will continue to be in accepted state. So something that I want to highlight here is still you're stuck at 96 GB. And now what we'll do is we will do that magic. We'll use that magic wand, the YARN optimizer. We'll specify the queue capacity strategy. And the moment you play that magic wand, automatically you will see now these jobs will move from accepted to running state. And also the total YARN, total memory will also increase. And that is something I'll share. Just refresh the screen. So previously the total resource was 312. Now it has moved from 312 to 327. And now the jobs that were stuck in, so if you see here, previously we were stuck at 95 GB. We have moved from 95 GB to 105 GB now. So you're unleashing that potential. All right. So if you see, this is the entire thing that we want you to let you know that, hey, I mean, though at one point in time, it was like the jobs were stuck in running state, sorry, in accepted state. But when we have tuned this with the help of YARN Optimizer, now you are able to, overcome it and run the containers that were actually running in, that were stuck in accepted state. Right. So yes, these jobs are in running state. Right. All right. So some of the production ROIs that we have seen over a period of maybe I would say 8 to 9 months. Something that I want to stress on is this is a very new project. And when I say new project, I mean this thought evolved maybe I would say 15, 18 months back. And I think the team has done a fantastic job in delivering this. And we have some customers who are gaining lots and lots of in fact, they are benefiting out of it in short, right? And their return of investment on this project and by utilizing this feature is high. And just to let you know, we have started with memory. Now, based on customers' inputs and customers' requirement, they are pushing us to also come up with some similar feature that will help them to overcommit their CPU. So the entire engineering is fully focused on it, and you will get to hear more on this by the month end, mostly that is May 2025. All what I'm going to put across is, yes, we are place. We are a lab of innovation. We are here to, we are basically here in an industry to solve industry problems, right? So keeping all this thing, taking all this feedback, and we work rigorously and wholeheartedly to make sure that we solve industry problems. So just want to, give you a quick sneak peek of what is the ROI in production clusters. Yeah. Next slide, please. So if you see something, but if you don't mind, can you please zoom a bit? Perfect. Yeah, maybe that helps. All right. So no worries. I think that should be good enough. So if you all what I'm trying to put across is without YARN Optimizer in this slide, what we are trying to showcase is a particular job was taking 5 hours, 6 hours, close to 6 hours. But the moment we have introduced YARN Optimizer, it has come down drastically to a couple of hours, between 2 hours to 3 hours. Right? A significant drop in terms of the job execution time. Pradeep, yeah, maybe next slide.
Yeah, just to add to what Adnan has said, so this has happened because we are able to spawn more containers at the same time, right? Because earlier it was that current allocations would have exhausted the yarn cluster, but now we are able to spawn more containers at the same time, so latency has reduced.
Right. Pradeep, next slide. So here, if you see the overall thing for a particular job, it used to take like 7.79 hours. So we were even able to, reduce this time for the same job. If you keep a close watch, the username is this, which is very cryptic to read out, but it took like 7.79 hours. Can you please go to the next slide? Now that has dropped down from 7.79 hours to 5.75 hours, which is a decline of almost like 27%. All right. I think this is a big achievement and something we are very proud of to showcase that, yes, we are, I mean, it is actually helping in production. It's not just, theoretical, it is helping customers in production environment. Next slide, please. So this is a runtime comparison. A significant difference, right? If you see previously, we were spending like 1,200 hours in all together, right? The total runtime. Now that runtime has declined from 1,200 hours to 800 hours, right? I can guarantee you that the day you start utilizing this product and this feature, I mean, definitely you'll have to go through multiple cycles wherein we are here to help you in that journey, but you will unleash the potential as and when you utilize it in your day-to-day operations. But yeah, this was again a big impact that was observed in one of our customers' environment. These are a few metrics which helps you to understand. So I don't want to spend much time, but all what we are trying to showcase with this slide deck is there are many dashboards that we have come up with, which will help you to understand that, hey, how much is unleashed, how much is being optimized, and how much you're really utilizing and capitalizing on. So the first chart that you have is at the entire cluster level, and the next chart is for a particular node. Next slide, please. This is then again a production ROI, memory usage, actual memory used as compared to what it used to be in past. So if you see the metrics that we are populating here is optimized node memory, allocated memory, and used memory. Something that I can always vouch on is, I think with Pulse we are able to unleash so much of data in terms of what is really utilized, what is allocated, what is the wastage. And I'm not sure if there are any tool that will help you to discover that easily with a matter of few clicks. Right. That's it from my end. Thank you for listening patiently. Open for Q&A. If you have any questions, please drop your questions here. I will be more than happy to answer here. If not, reach out to our sales team, reach out to all our channels that we have, marketing team, sales team. We are also available on various channels. So you can reach out to us in any form, in any fashion. And if you are looking for more help on YARN Optimizer, we are here to help you out. And it's not just me, the entire team, the entire task force is here to make sure that we help you to solve the industry problem. We are more than happy to organize these sessions for a customer specific session and deploying it in your environment and showing you what is your ROI in your environment. That's it. Thank you.